In the last video, we found out how easy it was to add smashable bricks to our Brickout game by using pygame's.Sprite and Group classes. For homework, I suggested you collect the paddle code into a Sprite class. I've done that, plus a little bit of additional refactoring. This is Brickout 4.0 refactored.py, which is available in my GitHub repository with all of the other code for this series. There's a link in the description. I'll just give you a quick orientation, and then we'll improve the gameplay by adding sound and scoring in Brickout 5. I've given the ball sprite an in-play attribute. If the ball touches the bottom of the screen, which it checks in its update method, it is no longer in play. As I mentioned, I've collected the paddle code into a paddle sprite class. And in the game loop, if the ball is in play, I check for collisions with the paddle using Sprite Collide, just as we did previously with the bricks. One other important change is with the drawing. Previously, we were blitting the background each time through the game loop, and then drawing the ball, paddle, and all of the bricks over it. We can improve the efficiency of drawing by sending each group the clear message before we update. Instead of redrawing the entire background every frame, each group will clear just the area where its sprites were previously drawn. This copies the background only in those regions, which is more efficient. Check out the code in my GitHub repo if you want details, and drop a comment below if you want to talk about any of it. Now, let's add sound, so we have both audio and visual feedback for our ball collisions. The Pygame library has support in its Mixer module for streaming sound, which is appropriate for background music, and playing individual sound effects. Pygame by default can play several short sound effects at once using multiple channels. To add sound to our game, we will do the following. First, initialize the mixer. Second, load the sounds we want to use from files. And third, play the sounds at appropriate times during our game. I've downloaded some sounds that I like from freesound.org, and I've linked them in the description. I have 3 sounds: square blip non-fade for the sound of the ball hitting the bricks, boink for a wall hit, and I just changed the pitch of that same sound for a paddle hit, and game over for when the ball hits the bottom of the screen and is out of play. I edited game over because there were several different game over sounds in the file. All of these sounds are in the WAV format, which is an uncompressed format. On Freesound, I can see their specifications. 2 have a sample rate of 44,100 Hz, and 1 has a sample rate of 66,904 Hz. 2 are 16-bit, and 1 is 32-bit. The Pygame defaults are 44,100 Hz and 16-bit bit depth. So I brought the files into Audacity, which is free audio editing software, normalized their volume, and resampled them all to 44,100 Hz. I also exported them as 16-bit WAV files. This is not strictly necessary, since Pygame will automatically convert sounds to match the mixer settings, but standardizing them ahead of time helps avoid extra processing and keeps everything consistent. I have stored the sounds in a folder called Sound, which is in the same folder with my game. It helps keep your game folder organized if you keep assets in their own folders. It is a good idea to initialize the mixer after initializing Pygame. So at the top of the program, after initializing Pygame, I'll add pygame..Mixer.Init. A quick note for you audiophiles: if you ever want more control over audio settings like sample rate or latency, Pygame also has a mixer.pre-init function, which you can call before you call pygame.init, and you can pass in your own custom values. The next step is loading the sounds. I'm going to attach these sounds to the ball class, but you could make them variables that are part of the larger game. I'm going to make them fields of the ball class and give the ball play methods for each situation. This makes it very easy to experiment with the different sounds because they are all encapsulated within the ball. At the top of the script, in the imports area, I'm going to import path from the pathlib module with from pathlib import path. We will use the pathlib module to build the paths to the sound files through the sound folder so that they work on any operating system. And then in the ball init method, I'm going to create sound objects. That initializer takes a file path to the sound. So I'm going to construct the paths in the arguments. I will first create an operating system appropriate path to the sound folder with sound folder equals path sound. And then for each argument, I'll use that and the / operator to join the path parts to each individual sound. For example, self._wall_bounce equals pygame..Mixer.Sound, sound folder /boink.wave, and self.BrickHit equals pygame.Mixer.Sound, sound folder /squareblip_non-fade.wave. Once I've written that, I can write some methods to play the sounds. I'll write, for example, def play wall bounce self returns none, and here's the code to play a sound. pygame.mixer.sound.play, and then I simply pass in the sound, self._wall bounce. I'll write similar methods, play brick bounce, play paddle bounce, and play out of play. And we're going to play some of those down in the game loop. Let's figure out where. I currently send the ball group the update message, and then I'm checking if ball in play. And if so, I have the two checks for collisions, with the bricks and with the paddle. Let's do the paddle first. If the ball has collided with the paddle, I want it to play its paddle bounce sound. So in the conditional code, I'll add ball.play paddle bounce. For the bricks, I'd like the ball to play the brick sound for every brick that has been collided with. So I'm going to change that code a little and write bricks equals pygame.Sprite collide ball, brick group, true. Bricks will then be a list of bricks the ball collided with. I can write if bricks, ball.bounce. So it bounces once if it hit any bricks. Then I'll write for brick in bricks. So we will loop over all the bricks. Ball.play brick bounce. So the ball will bounce only once if it hits any bricks, but it will play a sound for each brick it hits. Now, for the wall hit sound, I want that to play when the ball hits a wall, and that code is in the ball's update method. So in the first three conditions, hitting the left, top, and right walls, I'll add self.playWallBounce. The self there means the ball will invoke its own method that's part of the ball class definition. And for the last test, the bottom of the screen, the ball will play the out-of-play sound. Let's run that. And we can hear the different sounds for the different collisions. I'll jump to a spot where we hit multiple bricks. Okay, let's add a scoreboard. To add a scoreboard, we'll first need to figure out how to score. Our game should have a limited number of balls, right now it's 1, and points should be awarded for each smashed brick. Let's get the scoring working first, and then we'll display it. Let's add to our brick class. We'll give it a points field, which will be initialized from a parameter, and we'll add a getPoints method, which will return the value of the points field. Down in the asset setup area, I'll pass in points for each brick. In traditional Brickout, the lower bricks are worth less. I'm going to increase the number of bricks just because I think it'll be more fun. So I'm going to change the constant numBricks from 10 to 15. And I'm going to add another row by adding another color to brick colors. Because the code below that is written generally, that's all we need to do to add bricks. But now we need to figure out points. Let's just use a points variable that will pass into the brick initializer, and we'll decrease it for each new row of bricks since we're building them from the top, the more valuable bricks, to the bottom, the less valuable bricks. So I'll start that off at 15, and I'll set points decrease equals points flooring division len brick colors, so that decrease will make sense even if we change the number of rows. I'll pass points into the initializer, and after each row, we'll subtract points decrease from points. Now let's print the brick points for the bricks that are hit, just to see that all that code is working before we continue. So in my for brick in bricks loop, where I'm playing the sound, I'll also just print brick.getPoints. This will ensure that the bricks know how many points they are and that each row has a different points value, more points for the deeper bricks. And we'll run it and check that out. Very good. Now let's create a scoreboard class that can keep track of all scoring and that can display itself. I'll define this above brick, and again, I'll subclass sprite. This will need an image and a rect so it can be drawn from a group. It will need to keep track of the number of balls and the points, so I'll give it fields for those values, _points and _balls. Let's pass balls in as a parameter. The points field will start at 0. And we should also pass in the top left coordinate so we know where to draw the scoreboard. But how do we draw the scoreboard? We're going to use the pygame font module to render text for the screen. A font is an object that is a typeface and size, and we can then ask that font to render text for us. Let's get something drawing, and then we can refine it. I'm going to give the scoreboard a font object as a field, and it will use that font object to render text composed of the current number of balls and points. In the initializer, I'll write self._font equals pygame.font.sysFont courier new 36. That will create a font object that will render text in 36-point courier new, provided that font is available among the fonts on the system, and if not, Pygame will substitute a font. Now let's just render Hello World to see how this works, and then we'll work on refining what we render and where it goes. When we call render on a font object, we pass it a string, and it creates a surface with that string drawn on it. So that will be the image for the scoreboard sprite. Let's go through the render parameters. Self.image equals self._font.render hello world. That's the string. And then we pass in a Boolean for whether we want that anti-aliased. I'm going to pass in true. And then the color of the font, I'll pass in white, 255, 255, 255. And the color of the background, which will improve the anti-aliasing. That's black, 000. That will return a surface, which is the scoreboard sprite's image, that text rendered in that font and that color. To set its position, we'll write self.rect equals self.image.getRect and self.rect.topleft equals xy. So the process is create a font, which is typeface plus size, then send it the render message with a string and some other arguments to get a surface of that text rendered in that font. We can then blit that directly, but here we're making it part of our scoreboard sprite, so we're using the sprite's rectangle to locate it. We only need to create the font object once, which is why I've made it a field of the scoreboard. Let's create a scoreboard sprite down in the assets area, and we'll put it at 00 for now, and then we'll put it in a group, and send it the clear and draw messages, and run the game. Okay, and you can see our message partially hiding behind the red bricks at the top, but it's there. We'll need to adjust our screen real estate a little bit to have a nice scoreboard. Let's start the scoreboard off at 5.5, and we'll start the bricks at 2.5 times the brick height, and we'll increase the screen height to 450. That gives us room for the scoreboard and keeps the distance between the paddle and the bricks. You can map out the proportions you want, but that's what I'm going to keep for now. Now let's work on having the scoreboard show the actual score. The score is going to update each time the player smashes bricks. So let's add an add points method to the scoreboard and send the scoreboard the add points message for each brick that is smashed with scoreboard.addPoints brick.getPoints. We'll add an update method to the scoreboard in which we re-render the score. Before we do that, let's just finish up in the game loop. We are already drawing the scoreboard. Before that, let's update the scoreboard so it creates its new image. And above, where we're clearing the other groups, we're also clearing the scoreboard. Now let's go write update for scoreboard. I'm going to render a string that will be something like score, and then the points, and balls, and then the number of balls. So self.image equals self._font.render f score, in curly braces, self.points, some space, balls, in curly braces, self.balls. And then I'll pass in the same parameters as before, true, white, and black. Every time we render text, if it's different text, the size of the resulting surface might be different. So we'll need to get a new rectangle and relocate it. So I'm going to get the top left coordinate of the rectangle with top left equals self.rect.topleft. Then get the rectangle from the surface with self.rect equals self.image.getRect. And then I'll set it to its old location with self.rect.topleft equals topleft. And of course we'll want to do the same thing in the initializer and not have the score initially be hello world. I'll copy that code into the initializer. I probably will end up refactoring this into a create surface method I can call from either, but for now I'll just copy the code. And if we run that, we can see it's good, it functions, but I don't love the way it looks. What I'd rather have is a slightly smaller font size, and then I'd like the score to be flush left and the balls to be flush right. I'm going to suggest you pause the video and see if you can adjust the score as I've described. I'll give a hint. I'm going to pass the screen in to the initializer and the updater to do this. Pause the video and come back and see how I did it. How'd you do? So I did create the helper method, and I called it _createSurface, beginning with an underscore because it's meant only to be used internally by the Scoreboard class. I invoke that from the initializer, passing in screen, x, and y. I did add a screen parameter to the initializer here and where I create the scoreboard down in the assets creation area. I did change the font size to 32. And in update, I invoke it again, but this time passing in self.rect.left for x and self.rect.top for y, because that's where we have the location information stored in the sprite's rectangle. And again, I've added screen as a parameter, and I pass it in to update down in the game loop. Within Create Surface, I render the text in two pieces, and I call those surfaces left score and right score. So pretty much the same as before, but I split it up into two surfaces so I can blit one flush left and blit the other flush right. I then create a surface for the sprite's image that is the height of left score and the width of the screen minus 2 times the x offset. So that offset gives us a little space on the left and on the right. And I blit the left score to the left at 0, 0, and I blit the right score at the width of the image surface minus the width of the right score surface. That's it. Now we have a scoreboard that's keeping track of our score as we play. So for homework, see if you can give the player more than one starting ball, display the ball losses in the scoreboard, and let the player introduce their next ball with a keystroke such as the spacebar. This will involve changes throughout the game, but you know everything you need to know to do it. If you get stuck or want to share your victories, please drop a comment below. And as always, have fun and keep coding.